Hello students, welcome to this second lesson in the first module of the course on trigonometry. In the first lesson, we studied about angles and degree measure. We looked at the definition of angle, the concept of rotation clockwise and anti-clockwise, and accordingly positive and negative angles. Then we looked at degrees, minutes, and seconds, and we did some practice problems in that area. Okay. In today's lesson, we are studying the radian measure, which is very important when we do proper trigonometry. We measure the angles in radians. That is actually the scientific, the SI unit of angle. And related to this radian, it's going to be related to the circle. And in the circle, we have arc and we have sectors. So we will be looking at the arc length of a circle, a formula for that, and the area of a sector of a circle. Okay, so let us get started. First, we begin with the concept of unit circle. What is a unit circle? As the name says, unit means something is unit, right? That is the radius. If you have a circle whose radius is 1 unit, it's a unit circle. So you have this unit circle pictured here. And this particular unit circle is more special. Not only it is a unit circle, but it has been positioned very nicely, right? The center of the circle is at the origin and the radius is 1 unit. So this coordinate here is 1, 0. The one on top is 0, 1. And I want you to go ahead and write the coordinates of the other two intersections with the axis and tell me whether you wrote that for the negative x-axis and this for the negative y-axis, right? So this circle is positioned so nicely. This is called unit circle in the standard position. Okay, so the diagram is there. If you want to describe, you will say center at the origin. That is enough. The moment it is a unit circle and center is at the origin, automatically the points, the intersections with the axis will be those. Okay. All right. That unit circle in the standard position is a diagram which we will come back to again and again. When we define trigonometric functions later, we will be looking at this again. Okay. Now, we are now looking at another measurement system of measurement of angle called radians. We have studied degree in the previous lesson. So the way we introduce radian here is with comparison to that. Okay. And because we know about degree, from our school, like earlier studies also, so it becomes easier, right, as a reference. So what is the connection? The connection is if you make one full rotation of a circle, one full rotation, in degree measure, that is 360 degree, right? You call that the full angle, full rotation. In radians, that turns out to be 2 pi. 2 times pi. The pi, whose value is 3.14159. That irrational number. Okay. Now, don't ask me why. We're not getting into that here. This is one of the fundamental constants of nature, I would say. Any circle you take, if you divide the length of the circle by its radius, you get 2 pi. Okay, which by the way is going to be related to the concept of arc length just in a second. Okay. For now, we just memorize it. 360 degree or the full circle is 2 pi radians. Now for conversion, something else is more useful. which is one straight angle, like from one side of a line to the other side of the line, we call the straight angle. That is half rotation of a circle, right? Halfway. Maybe I can show here like that. That's half rotation of a circle, and that we know is 180 degree, right? And 360 degrees 2 pi radians or full circle. So half circle is pi radians. 180 degree equals pi radians. And that um, equivalence here gives these conversion formulas. Okay. Converting degree to radians and radians to degree. 1 degree, if you look at this formula, 180 degree is pi radians. So 1 degree is pi over 180 radians. See, we have these two, we are studying two systems of measurement, right? So obviously we need to know how to convert from one to the other. Like many times we'll need that. Just because if there are two, let's say, you are looking at two different data sets. In one of them, the angles are given in radians, and in the other one, the angles are given in degrees. But you want to do a comparative study, you need to be uniform, right? So we need to be able to convert. Okay. If you are wondering, why are we talking about conversion here? And 1 radian. Now, pi radians is 180 degree. So 1 radian is 180 over pi degrees. Okay. Now, one thing about radians is, for the degree, you have that symbol degree. Okay. For radians, you can write RAD, like rad, like that, or you can write full radians. Some textbooks you will find used a symbol like C, like that. Okay, to refer to one, like if it is 1 radian, they write like this. Or some literature online, you might find that notation. But sometimes nothing is written. Okay, if nothing is written, also it is understood to be radian. If you know that you are talking about angle. Okay. All right. Arc length and radian measure. Now this radian measure is significant in another fact that it gives a very nice formula to find the length of the arc of a circle. Okay. So what am I talking about? Let me draw a diagram. Say you have the circle and you look at an arc, let's say. Okay. From point A to point B on the circle. So of course it is a very interesting question, what is the length? I denote it by length S, let's say. That is a standard symbol for arc length. Okay. S. What is the, how to find it? Is there a formula for it? And it turns out that that is going to depend on the angle it makes at the center. Call it theta. Okay. It may, and that is kind of commonsensical if you think about it, because if you take a longer arc length, you are going to get a larger angle at the center, right? So the arc length is related to the angle. But what exactly is the connection? Okay, we want to understand that. So let us say this was a regular circle, not a unit circle. So it's, let's say the radius is some r. Okay. We will develop the formula actually with this table on the left side. Now you know the formula, by the way, the circumference of the circle is 2 pi r. Okay. We're not discovering the formula here. I'm only kind of justifying the formula, so you will tend to remember it. Okay. Because somebody might say the formula, the circumference is 2 pi r, comes from this arc length formula, right? So it becomes a game of whether chicken came first or the eggs came first. Okay, we are not getting into that. It is just a way to see the whole thing, or connect the dots, connect the whole thing together. Okay, so say we know this formula, the circumference is 2 pi r. So let's write that here. Now, when you have this whole circumference 2 pi r, let's say you take the entire circle as your arc. So the arc length is 2 pi r. And at that time, the angle at the center is 2 pi, right? 360 degree 2 pi, which means if the arc length is r, the angle at the center will be 1, 1 radians. Okay. And that means if the arc length is 1, the angle at the center will be 1 over r. Okay. And actually, I should have had one more row to do there. If the arc length is, or let me actually skip the middle one here. Okay. When it is 2 pi r, the angle is 2 pi. If you use this, proportionality concept, if the angle arc length is 1, the angle at the center is 1 over r. You divide by 2 pi r. Okay. So if the arc length is s, you multiply by s now, s over r, right? The angle at the center, and the notation for that is, let's say, theta. So the formula becomes, I will write first on the left here, theta is s over r. Okay, so you say s equals r theta, or theta equals s over r. Let me put bidirectional implication. Okay, these two formulas. So that is on the left side, we have arc length. This s is arc length. Okay, on the right side, here actually we're talking about this. Okay, is radius times angle. So the arc length is equal to radius times angle, or the angle at the center is arc length divided by r. Okay, so I will highlight these two formula and we will continue. Okay, now we will come to the general angles later. First, let us look at some standard angles and how they divide the circle into different components, so you get arc lengths of equal sizes. Okay, say you have a circle and you divide into 45-degree sections. So what will be 45-degree sections? One right angle is 90-degree. So a 45-degree is going to be half of that, right? Now let's do a small conversion here. 180-degree is pi radians. So 90-degree will be pi over 2 radians. And we take 45-degree, which is half of that also, will be pi over 4 radians. Okay. So 45-degree equals pi over 4 radians. And totally how many you will get? Count them. 1, 2, 3, 4 here. So 4 more on the lower side, totally 8 sections, right? Okay. We are looking at some independent ideas here. Okay, you might not find immediate connection. We will see later. What is the takeaway from here? 45-degree is pi over 4 in radians, and 45-degree or pi over 4 radians divides the circle into 8 components like this. each right angle is divided into two components. Okay. Similarly, if you divide the circle into 30-degree sections, now how many such will be there? The right angle is 90-degree. So if you have 30-degree sections, you are going to need three of them, right? 30, 60, 90 total. So you will have 1, 2, 3, 4, 5, 6, and 6 more down here, totally 12 sections. Oh, by the way, I can use this itself to give the conversion formula. Okay, that is one more use of this idea. You have 12 sections, so 12 30 degrees will be the full circle, right? 2 pi radians. Okay, that means 130 degree will be 2 pi over 12 radians, which is pi over 6. So 30 degree is pi over 6 radians. Okay, right? And so on. Okay, you can do like this for other standard angles. So first of all, the standard angles are 0 degree, 40, 30 degree, 45 degree, 60 degree, 90 degree, and their multiples. Okay, the reason they are called standard angles, you will see later in trigonometric functions, those angles have some easily computable nice values. Okay, and for other angles, it's not so easy to find the values of the trigonometric ratios. So these are called standard angles. Okay, they are well known. Okay, so we saw two things here. 45 degree is pi over 4 radians. 30 degree is pi over 6 radians. And I talked about the connection. Okay, if you look at 30-degree sections, totally there will be 12 in a circle, which is 2 pi radians. From there we get 30 degrees pi over 6 radians. Okay, and then we can continue that for other angles. So instead of more diagrams, I'll just summarize it in a table, and you write it down and try to memorize as you write it. Okay, these are the angles that you will use very frequently, so it's worth memorizing instead of having to look up every time. Okay, I will start with, let's say, pi radians. You know that is 180 degree. Pi over 2 radians is 90 degree. Pi over 3, think of that, 60 degree. Pi over 4 is 30 degree, sorry, 45 degree. We saw that earlier, half of 90. No, pi over 6 is half of pi over 3, which is 30 degree, or 180 divided by 6 is 30. These are standard angles. Don't have specific other standard angles, so I'm just going to write the 2 pi is 360 degree. Okay, so the title is frequency of frequently used conversion. Okay, so frequently used, hence just memorize them. Okay, let us do some practice problems. The first one, convert to radian measure. 40 degree to radian measure. What will you do? 40 degree times 1 degree is pi over 180 radians. Okay, simplify that, you will get 2 pi over 9. Learn to use calculator to do this kind of work. Okay, generally, you are expected to leave the answer like this and not write it in decimals. So you have to, when you use a calculator, there will be an option of getting your answer into fraction mode, not decimals. Okay. So on your particular calculator, see where is that option. If you are able to do mentally or by hand, that's great. But if you rely on a calculator, make sure to know how to do that. The next, convert to degree measure. So you have 17 over 12. Okay, that's a number I'm not going to touch. But what about pi? This is from radians to degrees. Okay, pi radians is 180 degree. Let me directly use that conversion. Pi radians is 180 degrees. Now you cancel 180 with 12. That you are going to get 15. Right? So 17 times 15 is how much? 15 times 15 I know is 225. Fun fact to know. Another 30, so that's 255. Okay. In degrees. The next work is you have to use calculator. Okay. Convert to degree measure to the nearest thousandth of a degree. And there is a specific instruction. Use the pi button on your calculator. Okay. So in your calculator, you will find a button for that. I'll just pause and write that. Okay. I typed in the calculator like this. I took that number negative. Again, you have to find that negative sign in the calculator. Okay, you cannot use the minus, the regular minus sign. There is a separate negative sign to use if there is a negative at the front. 1.924 times, right, 180 over pi in degrees. Now I use the pi button on the calculator to write that pi, and I got the value minus 110.24. I'm rounding up to or nearest thousandth. I need to do to 3 decimal places. Okay, so it will be 237. Round it up to 3 decimal places. Okay, in degrees. You also do it on your calculator and check. Next, convert to radian measure and round to 3 decimal places. Use the pi button. If it was only the 187 degree, would have been easy, right? But we have these other stuffs also, so a little bit more work. Luckily, not that much. Okay, on your calculator, you are going to type 187 plus, right? Use parentheses. Okay, all this in calculator. 49 divided by 60, because you have to convert it to degrees before you can convert to radian, right? You have to have the whole angle in terms of only degrees. Plus 36, remember, divided by, that is 36 seconds. So you divide by 60 and again divide by 60, which is 3600. And now it is in degrees. Okay. But I'll not write the degree. What I will do is I'll multiply this now with 180 divided by 5. Oh, no. I did the opposite. I am converting to radian. Times pi divided by 180. Now that is in radians. Okay. So in your calculator, just do this. Type that in your calculator. Okay. Okay. So I couldn't change easily into a screen with the Texas Instruments calculator. So I'm simply showing you the calculator on my iPad just to give you the focus on some important things here. Okay. When you type on calculator, make sure to use the parenthesis and the appropriate number of parentheses. Okay. For example, in this case, it's 180 plus 49 divided by 60 plus 36 divided by 3600. You don't need parentheses there because if you remember the PEMDAS or BODMAS or PMDAS rule, you study in school on the precedence of operators, right? Division comes before addition. So everything inside those parentheses here will happen in the correct order. And then you have those parentheses times, now that is in degrees, right? Times pi divided by 180. Again, you don't need parentheses because multiplication and division have the same precedence. So it doesn't matter which one is done first. Okay. So in the same way, in an equivalent way, you have to type in your calculator, right? And then hit equal to, and you have your answer 3.156. Okay. I'll switch back. All right. 3.156. Okay. Next. Find the radian measure for two positive and two negative angles that are coterminal with this. Recall that we did a similar problem with degrees in the previous lesson. Now, if you are doing the same thing in radians, recall the definition of coterminal. They differ by 360 degrees, right? You make one full rotation, whether clockwise or anti-clockwise, you come back to the same angle. They will be coterminal. So that was in degrees 360 degree. If you are doing the same thing in radians, of course, you will subtract, right? 2 pi. You will add or subtract 2 pi. So the two positive part, two positive angles coterminal to this will be that angle plus 2 pi and that angle plus 4 pi. Every time you add a multiple of 2 pi, you come back to the same angle. They will be coterminal. Okay, so let me simplify that expression. Bring the whole thing to the left. Okay, and that will be equal to 17 pi over 6, and then that is 29 pi over 6. And for negative angles, you will subtract to make sure that they are actually negative. And I can do a mental calculation and know that this is negative. Okay, I'll show that in a second. In the same way, subtract multiples of 2 pi to get smaller values. The first one would be minus 7 pi not 17, minus 7 pi over 6, and the second one would be minus 19 pi over 6. Okay, coterminal angles. Okay, the next question. Question number 6, asks you to find the quadrant in which this angle lies. It is the same as question number 5 in an indirect way. Okay. Now take that angle and try to keep adding or subtracting 2 pi until you get a small enough angle between 0 and 2 pi, which will tell you the quadrant. So for the first one, I'm simply going to add 2 pi to get a coterminal angle. And see what do you get. 16 minus 11 plus 16 would be 5. Okay, 5 pi over 8. Now, in which quadrant is 5 pi over 8? A simple comparison. here is how I do it. Okay, 5 pi over 8 is here in the middle. It is definitely less than 8 pi over 8, and it is definitely more than 4 pi over 8. Okay, that is the technique for comparison. I'll change the color for clarity. Okay, so what does that give you? 4 pi over 8 is pi over 2. You will wonder how did I know what number to choose? That is where the knowledge of standard angles comes into picture. Okay, remember the quadrants are those 0, 90. Quadrants are between 0 and 90, 90 and 180, 180 and 270, right? Now I know that 90 degrees pi over 2 radians. So I'm going to look at 0, pi over 2, pi, 3 pi over 2, which is 270 degree, 3 times pi over 2, which is 90 degree. That then finally back to 360 degree, which is 2 pi or 0. Okay. Hence, I chose that 4 pi and 8 pi strategically. So between pi over 2 and pi, what's the quadrant? And you guessed it right. That is the second quadrant. Okay. Just draw the circle. It will be clear. 0 is here, pi over 2 is here, pi is here. Okay. Second quadrant. First quadrant, second quadrant. Okay. Let us do a similar exercise for 23.1. Now that's not decimal. Okay. So you will have to use a calculator here, first of all, because pi is going to be 3.14. It has those decimal values. So in order to get a sense and to go there. So before I do that, I would want you to have a roughly an idea. Pi, what's the value of pi? I'm going to write this extra work on the left side here. Pi is approximately 3.14, right? So 2 pi is approximately 6.28. Okay, so one full circle is 6.28 approximately radians. That means 23.1 here. And I'm trying to connect that with that 6.28. Okay. And the nearest I can think of is 6 times 4 is 24. This 23 is a little less than 24. So I'm assuming at least 3 multiples of 6.28 will go into that. Okay. So what I'm going to do is I'm going to subtract 3 times 2 pi. 3 multiples of 2 pi I'm going to subtract 23.1 in a calculator. Okay. And maybe I can do that live in front of you. Let's clear this. 23.1 minus 6, 3 times 2 pi. Okay, that is 6 pi. Use the pi button. What's the value? 4.25. Okay, radians. I'll write that and I'll come back to you again here. 4.25, just approximately. Okay, approximately 4.25 radians. Now you might wonder, how many multiples of pi over 2 this is, right? It's not super clear. What you do is, this is 4.25. Now this is a very nice trick. Okay. Divide by pi over 2 and multiply by pi over 2. Why am I doing this? This will tell me how many multiples of pi over 2 this angle is. Now I need to compute the value that I put in the box here. Okay. and that value is going to be again approximate, so I'm going to use approximate symbol, something times pi over 2, and I'm going to evaluate that 4.25 divided by pi over 2. So back here, this is my answer, divided by pi divided by 2. Okay, so divided by pi over 2. It will automatically take care of the order here. Okay, in fact that 2 will go and multiply 4.25, but that happens automatically, you don't have to worry. Okay, what's the value? 0.676, or let me round up 0.68, doesn't matter. So it's basically 0.68 of pi over 2, or 68% of right angle. So what does that tell you? It's in the first quadrant. It's less than a right angle. Or something seems off here. I'm sorry. Give me a second. Oh, no. I said something a little incorrect earlier. My bad. Let me actually go back. Okay, so it was 4.25. I'll clear everything and keep 4.25. A little bit. Okay, so that is why it is important to be careful in calculations. I should have put parentheses. I said that the division will take care. It won't. It will have the opposite effect actually. Sorry. If I don't use parentheses, it's going to divide by pi and again divide by 2. I don't know what I was thinking. You are dividing by pi over 2, right? So that thing should be in parentheses. If you do this now, the effect will be that 2 will multiply with 4.25. Okay. Luckily, I had a sense in my mind that 4.25 is more than pi, so it should be more than 180 degree. I was expecting it to be in the third quadrant, but when I saw that it is getting in the first quadrant, I spotted my mistake. Okay. So use parentheses, super important. Now you'll see 2.7. So I'm ignoring other decimals, it doesn't matter, approximately 2.7 pi over 2. What that means is, if you look at the four quadrants, 1 pi over 2, 2 pi over 2, and 3 pi over 2 will bring you to the 270 degree, right? 2.7 pi over 2 is somewhere there. So that is the third quadrant. Okay. A very good exercise, by the way. Next. See, we do a lot of practice problems in these lessons, okay? And I have included all of this in the note-taking guide. So I want you to have enough, resource materials when you are starting to work on problems in the homework on your own, okay? Next. Find the measure in radians of the smallest positive angle, that is coterminal with 19 pi over 2. Okay, the same idea like what you've done in the previous lesson. You want to get the smallest, so you are going to go on subtracting multiples of 2 pi until you get something between 0 and 2 pi. But you can make a guess. 19 divided by 2 is 9.5. Okay, you can do that calculator work. 9.5. So I know I can subtract 8 pi. Okay, if you're not following what I'm saying, I'll just show you here. We have 19 divided by 2, right? That is 9.5. So I need to bring this angle down to between 0 and 2 pi. So how many multiples of 2 pi? 8 pi is a multiple of 2 pi. So I'm subtracting 8 pi. And that will give me 9.5 minus that, it will be 1.5 pi. Okay. Okay, that is in decimals. If you write in fraction, you write 3 pi over 2. That's it. That's the answer. Okay. Add, because, okay, if you subtract 2 pi after this, it will go to the negative territory, right? We want the smallest positive angle. Hence, we stop at 3 pi over 2. Okay. So this is a very simple exercise. Just to give you practice in dealing with these radian measure angles in fractions. Okay, express the result in terms of pi. So just add them. And in case you have forgotten, so that is the reason I wanted to include this problem here. This is the technique of adding fractions, right? You multiply with common uh, components, like common denominator. You multiply in such a way that you get common denominator. 4 times 3, 4 times 3. You know, in a way, cross multiply, like whatever is missing, you multiply with that. And that gives you 4 pi over 12 and 3 pi over 12. That becomes 7 pi over 12. Okay, you will be doing many such exercises in your work. Next, now we're doing some arc length stuff. Find the length of the arc intercepted by the given central angle alpha in a circle of radius r. Okay, so angle is given, radius is given, you have to find the arc length. And let us recall the formula. Arc length S is alpha r. I think I would have written theta r earlier. Angle, right? Alpha r, let's say. And the angle must be expressed in radians. Only then you use the formula. That is important. Okay. So for example, in this case, you don't say S is 60 times 2. Okay, that will be incorrect. You need to convert that angle to radians. And for that, so this is not correct. What is the correct thing? The correct thing to do is 60 degree is pi over 3. Remember one of the standard angles, conversions that I asked that you have to remember. 60 degrees pi over 3. So the arc length here is alpha r, which is pi over 3 times 2. Okay, so that will be 2 pi over 3 meters. Write the unit when it is available. Okay. All right. Find the radius of the circle given the central angle alpha and the corresponding arc length. Okay. Now, what was the formula for the radius? Radius will be, let's change the color. Radius is arc length divided by angle. See, S is R alpha. So you can, play around with the formula. And the arc length given here is 8 millimeters. Angle given is 36 degree. But that has to be converted to radians. Pi over 180. So that 36 times pi over 180 makes it into radians. Okay. And you can use a calculator, but I know this luckily. 36 times 5 is 180. Okay. So that 5 can go up and become 5 times 8 over pi. So that is 40 divided by pi millimeters. Okay. If you have to get it in decimals, the question doesn't say here. So when it says do that. Get the value in decimals. Okay. Next up, we talked about the arc length, right? What about the area? So what we are talking about here is this. There is a circle, and let's say you have a sector, right? The angle at the center is alpha. The length of the arc is S, let's say, this part. The question is, what is the area? Area of just that sector, okay? And the formula is directly developed here in one step, doesn't require more than one step. What is the idea? The full circle is pi r square, right? And that is when angle is 2 pi. Angle is 2 pi, the area is pi r square. So angle is 1, area is 1 over 2 pi r square. Okay. And when the angle is alpha, alpha over 2 pi times pi r square. And there pi and pi cancels and becomes alpha r square over 2. Okay. That's how you get the formula for area of a sector. Let us do that here. Find the exact area of the sector with the given information. Arc length is given, radius is given. You need to find the area of the sector. And area of the sector formula is alpha r square over 2. There are two ways of doing it. Okay. One way is, first we need to find alpha and then plug in, because we have the radius, 3950, but we don't have the angle alpha, right? But instead you are given the arc length S. So use that, the value of S and R to find the angle, then put it in the formula. So the first step I'm going to do is to compute that alpha as S over R. And luckily, both are in the same units, miles. So I don't need to worry about the units. That's my angle, alpha. And there isn't much to simplify here. I don't know. Don't get it too much into decimals. You can leave it like this and use a calculator. But in fact, let me show you that. So I'm not going to do any simplification at this step. We will see that we will punch everything in the calculator directly. Okay. Area is alpha r square over 2. Now alpha is 2000 over 3950. R is 3950 square divided by 2. Okay. And when you do this in a calculator, you know that one of them is getting cancelled. Okay, there's 13950 that's going to get cancelled here because there are two of them in the numerator. And oh, okay, I think this is doable by hand. You don't even need a calculator because 2000 divided by 2 is 1000. So basically you are multiplying things. So 3950 times 1000, which will be 3 more zeros. Okay. And units are very important. Okay. This will be miles squared or square miles. Okay. And what about this? You are given, see the way the arrow is pointed, what they mean is that arc length is 800 meters. Okay. So S kilometer, 800 kilometer. And the angle at the center, alpha, is 7 degree. And you know that you need to have the angle in radians in order to find the area. So I'm going to convert it to radians. And that is very easy because you just have to multiply by pi over 180, and 7 does not cancel with 180. So it stays like that. So you have the arc length, you have the alpha. Now, this time I'm going to use a different method. Okay, I was saying there are two methods, if I were to do like before, I would compute the R, which is S over alpha, and then plug in the value of R in the area of the sector formula, right? Alpha R square. You already have alpha. If you compute R, then you can plug in and you're done. But let me do it this way. This time I will follow the second method I was saying. Area of sector is half alpha R square, right? But I don't have the R. I have S and alpha. So I'm going to write that R in terms of S and alpha whole squared. Okay, and when you simplify that, half alpha times S square over alpha square, right? The laws of exponents, I distributed the square numerator and denominator, and that becomes S square divided by 2. Now I'm writing it in a simplified way. 1 alpha cancels with 1 alpha, so you're left with S square divided by 2 alpha. So what I'm going to do now is I'm going to punch that in the calculator. I'll continue here. S is 800 squared divided by 2 times alpha is 7 pi over 180. Okay, I can do the rest of the work in calculator. Let me just cancel this on 90 2 and 180. So 7 pi over 90. That we will now type in a calculator. Okay. Let's assume the area we have to be found in decimal places with up to 2 decimal places. Okay. Now I had not written that, but I'm adding that now. Find area to 2 decimal places. Accuracy. Okay. 2 decimal places of accuracy. And 800 squared divided by 7 pi divided by 90. Let's do that in the calculator. 800 squared divided by parenthesis. I'm not going to forget this time. 7 pi divided by 90. Okay. And what did that give us? 2619235.63. 2619235.63. 26319. Sorry, 2619235. Look at the memory problems in our modern times. Okay. Sorry. Point. Should have been able to remember this actually in one go. 63. Kilometers squared. Okay. You can do it anyways. Okay. We did a lot of problems. This will be in the next video. See you.